Okay, hi guys. We are starting Unit 3, which is on exponential functions and logarithmic functions. And so this is going to be 3A, which is going to be an introduction to exponential functions. And this one is going to be a little bit longer than normal just because there's a lot of base knowledge that we need for the unit. So if you guys need to pause or go back at any point in the video, of course, that's fine. Just make sure you're going at your own pace and not stressing yourself out if you can. So first of all, what is an exponential function? So an exponential function is going to be any function where the input, so the x, is part of an exponent, right? So we have two main exponential equations that we're going to start with. We have y equals to a times b to the x, right? And we have y equals p times 1 plus r over t. And it's important to note here, in this case, the t is really interchangeable with x. We're just using it as an input because it represents time, but you can replace that with x if that is easier for you to remember. Either way, it's fine. That's the input. And then here we can see that the x is in the exponent. So both of these are exponential functions. And so what do these really mean though? Well, in this one, this is going to be the one we're mainly going to use for like theory problems. So if we just get an equation, some points, if we have to plug in something to a function, and there's no real like real world like situation going on, like it's not a word problem, we're usually going to get this function. And so what each of these mean is, so obviously y is y, x is x. It's important to note here, it's going to be a times b. There's a multiplication sign, right? A times b to the x, and a is not being raised to the x power, but b is. So b is going to represent kind of the rate of increase, right? So an exponential function is going to look like this or like this. And depending on if the b is higher or higher or higher, right, it's going to increase steeper or steeper, because if I have 3 to the x, right, that's going to be higher than 2 to the x because I'm multiplying 3 by itself some number of times as opposed to multiplying 2 by itself some number of times. And it's important to note here that in this case, if b is less than 1, then it's going to be this kind of function where it's going down. And if b is greater than 1, it's going to be this kind of function where it's going up. And why is that? Well, if we think about it, if we have a number that's bigger than 1, let's say 5, right, then every time we multiply it by itself, it's going to get higher and higher, right, because we're multiplying by 5. And so if we have a b that's 5, that's higher than 1, and we go further along the x values, we're going to get higher numbers, right? But on the other hand, if b is something that's less than 1, so say for example, or in between 0 and 1, so say for example b is a half, right, 0.5, well, every time we multiply 0.5 by itself or by something else, it's going to cut the total number in half. So as x increases, we're multiplying 0.5 more times, and the overall value, the y, is going to decrease. And then you're thinking, okay, well, that kind of makes sense, but what's the a? The a is going to be, for lack of a better term, the a is going to be the y-intercept. So the a is going to be the value of the y-intercept. So if the graph crosses the y-axis at, let's say, 0, 13, right, 0, 13, then the a is going to be 13. And why is that? Well, remember, for the y-intercept, the x has to be 0. And if the x is 0, then we're taking b to the 0th power, and anything to the 0th power is 1, right? So if we take b to the 0th power, that's 1. So if we plug in x for 0, b to the 0th power is 1, and so we're saying y is going to be equal to a times 1, which is a. And so whatever the y-intercept value is going to be the a. So that's what's going on with this function. What about this other function, this y equals p times 1 plus r to the t? Because that looks a little bit more complicated and kind of scary. And the good thing is, it's going to be generally the same idea. Now, this is the equation we're going to use for y equals p times 1 plus r to the t, or to the x, is going to be the function that we're going to use for mostly word problems. So stuff like if I have a savings account, right, and I have interest on that savings account, and I'm trying to figure out how much money I'm going to have. If I'm talking about the like size of a population of a town over time, if I'm talking about the like how much the value of a like car deteriorates over time, this is gonna be really used for word problems, right? And a lot of these values are interchangeable, but a lot of these like letter names are interchangeable, right? P doesn't have to be P; it can be, well, P and R, right? If we notice, are basically the same thing, because if T is X, right? If T is X, then we're raising 1 plus R to the T power. So we're raising 1 plus R to the X power. And so B and 1 plus R are basically serving the same function. And A and P are basically serving the same function. So once again, the y-intercept of this equation is going to be 0p, right? Because 1 plus r to the 0th power is going to be 1 times p is p, right? And so you're thinking, well, that kind of seems right, but what about the 1 plus r? What's the point of the other addition sign here? This is kind of confusing. What's going on? Well, in this case, r is going to be some kind of like decimal rate of increase. So we can say like 5%, right? We're going to write this as r is going to be 0.05. And so this is basically saying we're going to take 1, because 1 to any power is 1. 1 is not going to change if we multiply by itself. And we're going to add some rate. So if I have a 5% interest rate on a savings account, then I'm going to add 0.05 to that 1, and then multiply that by itself t times, and that's my base. So all this is really saying is the 1 is kind of our base unit. The 1 is kind of the part that we're never going to have to worry about. And the r is the rate. So if I have the population increases at 1% per year, it's going to be 1 plus 0.01, which is going to be 1.01. So let's do some practice, because that was a lot of stuff I just told you, and it can be hard to digest it if we don't see it actually in practice. So first one, we're going to use the AB to the X, because we're just seeing a regular equation, right? And that's just going to be our theory equation. So remember, it's A times B to the X. And so this is asking us to find f of 5, where f is 100 times 0.7x, and label a and b in this equation. So if we see this, it's going to be a times b to the x. Well, what are we multiplying? What's outside of the exponent? That looks like it's going to be 100. So I'm going to go with the a is 100, right? Because the a is outside of the exponent, and in this case, it looks like the 100 is outside of the exponent. And similarly, because the b is inside the exponent and the 0.7 looks like it's inside the exponent, it looks like we're going to have the b be 0.7. Now, in terms of finding f of 5, you can and will have to use a calculator for this, because we're multiplying it a ton, and it's just not easy or fun to do by hand. So you can try to figure out what that's going to be, and then get back to me. All right, so let's see. So yeah, we see a is equal to 100 and b is equal to 0.7 like we got. Now f of 5 is going to be 100 times 0.7 to the 5th power, right? Because x is equal to 5. F of 5 is saying x is equal to 5. And so that's going to value out to be about, I got 0.16807. And if we multiply that by 100, because 100 is the a, we get 16.807. And if you had something else, that's fine. You might have just made like a small mistake in your calculator, like put a 5 and like put a 6 instead of a 5, or something like small like that. So just go back, see if you got a different answer, if you can figure out why you got that answer, and yeah. And then let's look at this following question. So the population of Townsville is 1,000 people in 2020 and grows by 1% each year. Use the formula f of t equals p times 1 plus r to the t, because again, that's our word problem equation, to find the population t years after 2020 and find f of 10. So this is asking us to do two things. It's asking us to make an equation with the information that we have, right? And it's asking us to find a value of that function. So first of all, we can do this. What's p? Let's just go through one variable at a time. What's p going to be? Well, if we think about it, p is the like y-intercept, right? So it's the starting value. It's at 0. So because the input is time, right? Because the input is t in this case, it's going to be 0 years after 2020. So in 2020, what is the population? and that's going to be 1,000 people. So P is going to be 1,000. So we get f of t is equal to 1,000. Forgive my awful handwriting. 1,000. And then what's the r, right? Because we need the r. So it's going to be 1 plus something. Well, we say it grows by 1% every year. So the r is going to be plus 0.01 because that's the rate, right? The rate of growth is 1%, which is equal to 0.01. So it's going to be 1 plus 0.01. And then this is all the teeth power. So that's our equation. And then again, with the first question, it's going to be very difficult to calculate this by hand. So I would just grab your calculator again, see if you can figure out how to find f of 10, and then get back to me. Pause the video. All right. So let's see. So if we have f of t is equal to p times 1 plus r to the t. So first of all, this is just going into did we get the first part right? So yeah, so p is equal to 1,000, right? Because the starting value, the y-intercept is 1,000. R is equal to 1% or 0.01, right? So we're going to get f of t is equal to 1,000 times 1 plus 0.01, which is equal to f of t equals 1,000 times 1.01 to the teeth power, right? And we're usually going to want to simplify that 1 plus r into just some single number because it's going to be easier to work with. But you don't have to. And then we're going to plug in 10 for t. We're going to plug in 10 for x, right? And so we're going to get f of 10 is equal to 1,000 times 1.01 to the 10th power. And I got, for this little bit, I got 1.1046, and that's times 1,000. So it's going to be 1,104.6. And now the important thing to note here is because it's a word problem, because we're saying people, right? Where we can't just leave it like that. Like in here, we could just leave it like this as a decimal because it's just a theory problem. There's no application. It's not like we're counting something. But in here, we're counting people. And you can't have 6/10 of a person. So we're going to round up to 1,105 people. All right. Now, this is kind of the more complicated part of dealing with these two functions. So we're going to make an exponential function from 2 points. So there are a couple ways we can do this. First of all, if one of the points is a y-intercept, right? So if one of the points is 0 something, then we can use that point for the initial amount. We can use that point for a. So let's say we have 0, 5 as one of our points, right? We already know now automatically that the a is going to be 5 or the p is going to be 5 because that's the y-intercept, right? So we have 5 times b to the x. And now all we have to do to find the equation is figure out what b is. And so if we get another if we have another point, which we will, let's say we have 1, 1, right, as the second point, that's going to be 1 is equal to 5 to the b to the first power, and b to the first power is just b. So we're going to divide by 5 to solve for b, and we get 1/5 is equal to b. So then we already have our equation just like that, and it's going to be y equals 5 times 1/5 to the x, right? And if neither, so that's when one of our points is a y-intercept because we can just plug that in for a. And if neither of our points is a y-intercept, it's going to be a little bit more complicated. So I already typed it out, so I won't have to draw it because I would do a very bad job. So let's say we have 5/4 and 2/3 as our 2 points. Well, what we're going to do is we're still going to plug both of these in for y and x. So, right, so we have y equals ab to the x. So if we have 5/4, we're going to plug in 5 for the x, and we're going to plug in 4 for the y, and we're going to get 4 equals ab to the 5th. And then, likewise, we can plug in the same thing here and get 3 equals ab squared. And now this is the part where we're going to have a little bit of difficulty because it can be a little challenging. We're going to divide these two equations together, right, to remove so if we divide the equations together, let's divide the left side first. Well, what's 4 divided by 3? Well, that's just going to be 4/3. So we have that right here. the equal signs are just going to stay through. The a's are going to cancel out, right? Because a divided by a is 1. And then b to the 5th divided by b squared is b to the 3rd. And you might be thinking, why can we do that? What's going on? What the hell's going on there? Well, basically, because those two things are equal, right? If we divide everything, we're dividing the same stuff by the same stuff because it's all equal. So we can do something like that, and we get 4/3 is equal to b to the 3rd power. And then we can take the cube root of b to the 3rd to cancel out the 3, right? So if we take the cube root of this, we also have to take the cube root of this. So we get the cube root of 4/3 is equal to b. And I found that to be around 1.101. Usually in these cases, it's okay to bring it to like 3 decimal places. That'll get you to the same amount. And then we're going to plug that in with one other point. So let's plug it in with the lower point just because I don't like big numbers. So we're going to plug in the 3 for y, the 2 for x, and the 1.101 for b. And so we get 3 is equal to a times 1.10 squared, 101 squared, right? And now we just got to isolate the a and solve for a. We're just going to divide by 1.101 squared, and that's going to equal a. And I found that to be about 2.475, and so our final equation is going to be y equals 2.475 times 1.101 to the x power. And so basically what you got to remember here is all you're doing is basically plugging in the points, dividing them to get rid of the a, solving for b, plugging b in with another point, and then solving for a. So let's do some practice. We will have one of each problem. One where there's the y-intercept is given and one where the y-intercept is not given. So let's do the harder one first. So find the function that goes through 11, 2, and 1827. So pause the video right now, see if you can figure it out. I'll be right here. All right, so 11, 5. Our 11 is our x, so we're going to plug that in. So we get, and 5 is our y, so we're going to plug that in. So we get 5 equals ab to the 11, ab to the 11th power. And then we have 1827. 27 is our y, 18 is our x. We plug that in, and we get 27 equals ab to the 18th power. And now dividing these, I swap them around just because I don't like negative exponents. We get 27 over 5 is equal to b to the 7th. And now these are scary numbers, but in reality, we're going to have our calculators. So you can just plug this into your calculator, and it's not really that bad. So we're going to take the 7th root of b to the 7th, and 27 over 5, right, to isolate the b. So we have the 7th root of 27 over 5 is equal to b. And that's going to be equal to about 1.272. And so we can plug that back into our original equation, y equals a times 1.272 to the x, right? And then let's plug in our smaller point, 11, 5. So we get 5 equals a times 1.272 to the 11th power. And now let's just divide to isolate a, and we get about a is equal to 0.354, so we get this final equation. And again, if you've got a different answer, that's fine. Go back through. Usually it'll just be like some small calculator error, but if you can try to figure out where you got it wrong, or where you kind of derailed, that's great. Now let's do this other problem, which is going to give us the y-intercepts. We have find the function that goes through 0, 5, and 10, 99. And you can pause the video, try it real quick, and then get back to me. Okay, so because we already have the y-intercept, right, we already know that a is going to be equal to 5 because it goes through 0, 5. So we can just plug that in right away. Y equals 5 times b to the x. And now we can plug in the other point, 1099. We get 99 equals 5 times b to the 10th, right? And then we divide everything by 5 and take the 10th root to isolate b, and we end up getting 1.348. And so y is going to be equal to 5 because of the a times 1.348 to the x power. And here, all we're really doing is dividing by 5 and then taking the 10th root just to isolate b. Okay, so compound interest. So when we're using the y equals p times 1 plus r to the t, right, we're doing word problems, right? And a lot of the time, those word problems are going to involve some kind of interest. So we're going to have a savings account, or we're going to be paying a loan, and there's interest on some kind. And usually our time is going to be in years. So it's going to be 5 years, 12 years, whatever. But sometimes when we have a interest, it's compounded more than once in a year. And what do I mean by that? Well, I mean it's given. So if I have $1 in a bank account, right, and there's 50% interest, and it's only calculated once in the year, right, I'm going to have $1.50 at the end of the year, because you got 50% of that is going to be 50 cents, and we add 50 cents to that one time, and that's it. Or maybe it's calculated twice. So in that case, it's going to take 25% both times, because 25% plus 25% is 50%. It's going to give me 25% of what I have the first time, and then give me 25% of what I have the second time. And so we can use a formula for that. That's just a slight modification on p to the 1 plus r to the t. It's going to be, this can also be replaced with the p. I don't know where I wrote a, but you can do p if you want. P times 1 plus r over k to the kt. And k is going to be the number of times it's compounded in 1 year. So you can notice that if k is equal to 1, right, we're dividing by 1 and we're just multiplying by 1. So if k is 1, then that's just the equivalent of compounding once every year. If we're doing it monthly, right, k is going to be equal to 12. And what we're really doing here is, if I have that 50% interest rate again, we're dividing that 50% interest rate up over k number of times, for k times it's going to be compounded, and then we're multiplying the number of times we're compounding it by that much. For example, if I have 5 years and it's compounded once every year, it's just going to be r over 1, because we're not dividing up the rate, and it's going to be 1 times 5 because we're not dividing up the rate. But if it's divided up quarterly, we're going to be dividing the rate up by 4, but we're also going to be compounding it 4 times as much. So we're going to multiply by 4 up here in the exponent. And that's kind of a difficult concept to grasp, which is fine. But let's see if we can do a practice problem just to kind of get the hang of it. So suppose you open up a savings account with an annual interest rate of 5% and put $1,000 into it. Calculate the money in and after the year if it is compounded annually, quarterly, and monthly. So I'm going to give you guys a little while to do this, because there's 3 steps to it. So see if you can do it. If not, see how far you can get. See what you're having trouble with, and then just get back to me. Whatever you do is fine. We're all about trying to make sure we're getting to that learning path. Okay, so what if it's compounded annually? Well, that's just going to be the regular one time a year, right? So again, we're going to be dividing it by 1, and we're going to be multiplying by 1. So it's basically the same thing as normal. So we're going to have f of t is equal to 1,000 over 1.05 to the t, right? Because we have a r of 5%, so it's going to be 0.05, and we have 1,000 as our starting value, so that's going to be 1,000. So if we solve that, because we're only doing 1 year, so we're just going to take this to the first powers, which is not really doing anything, right? So if we figure that out, we just figure out that we have 1,000 times 1.05, which is $1,050. And now what about if it's done quarterly? Well, if it's done quarterly and k is equal to 4, right? In this case, k was equal to 1. So if it's done quarterly, that means it's done 4 times a year, so k is going to be equal to 4. So we're going to divide the rate by 4, and we're going to multiply the exponent by 4. And so we get 1,000 times 1.1025. I just did that math in one step, but if you need explanation, we're just going to divide 0.05 by 4, and then we're going to add 1 to that. And that's to the 4th power, because again, the time is only 1 year. And then, so we're going to multiply 1,000 times 1.05095, because that's what this is to the 4th power. I just did it on my calculator, so sorry about that. But again, if that's different than the step you took, you might have just put in the wrong numbers, whatever. And then we're going to multiply that out to get 1,050 and 95 cents. So as we can see, it's not really a whole lot different, but it is increasing in value. And now what about if it's done monthly? Well, if it's done monthly, there's 12 months in a year, right? So k is going to be equal to 12. And so if k is equal to be 12, you know the deal by now. We're dividing the rate by 12, multiplying the exponent by 12. And so we get 1 plus 0.00416 to the 12th power. And that's going to end up being 1,000 times 1.05116, which is going to be the same thing as 1,051.16. And so we can see it's not really increasing a lot, but it definitely does help. If you're compounding more, you're getting more out of it. So that's that. And now this is I promise this is our last model of exponential functions that we need to know. And that's going to be whenever we have continuous growth or decay. And what do I mean by continuous? Well, I mean it's going to be always happening. And so if it's always happening, then we're going to use this special formula, p times e to the rt, where p is going to be the starting amount. So p again is going to be whatever the y-intercept is. E is going to be a special constant that we're going to go over, kind of like pi, 3.14159. It's like something that's set in stone. We'll go over that in a minute. R is going to be the rate again. And if it's positive, it's going to be growth. If it's negative, it's going to be decay. And then t is going to be the time, or x. And so what is E? I just talked about that. But what does that mean? I said it was like pi. Well, pi is an irrational constant. Pi is 3.14159265359 and so on and so forth, right? And that's used to represent like ratios in circles. And E is kind of similar. It's an irrational number that we use to represent continuous growth. And so 1 plus 1 over k to the kth power. So that's the like kind of the backbone of compounding, right? Of compounding interest, like we just went over, is going to approach E as k gets bigger and bigger. So what's E? Well, E is about 2.718281, right? It keeps going on forever, but that's the first like 6 digits. And so if we have k equals 100, right? If we have 1 plus 1 over 100 to the 100th power, that's equal to 2.704813 and so on and so forth. If we have 1 plus 1 over 100,000 to the 100,000th power, we get 2.718268, closer and closer to E. And if we have 1 plus 1 over 100 million to the 100 millionth power, we have 2.71828, and it's 2.718281, and that's going to be different than E as we get to smaller and smaller digits, but it's definitely getting closer and closer to E, right? And so another way we can think about it is E is going to be equal to 1 plus 1 over infinity to the infinitieth power. So k is equal to infinity means that E is equal. That means that this is equal to E. So the formula we're going to use again is going to be P times E to the R T, and R and T are going to be in that exponent. So let's do some practice. Radon 222 decays at a continuous rate of 17.3% per day. How much will 100 milligrams of radon 222 decay after 3 days? So this is asking us to make an equation first of all. So let's get our variables. What's our P? What's our starting value? Well, they already say we start with 100 milligrams. So our P is going to be 100, right? Our P is going to be 100. And then we have E. We don't ever have to calculate E. E is never going to change. And good thing about E is that your calculator will usually have like an E to the X button. So if you type 100 and then you type times, there's usually like an E to the X button you can write, because this is a lot of what we use E for. And then what's our rate? So our rate is going to be 17.3% per day. But remember, we need to write that as a decimal. So it's going to be 0.173. And then it's times X. But X in this case is going to be 3 days. So can you see if you can calculate that? See if you can calculate that in your calculator. I got to go grab water really quickly. So while you're doing that, just see what you get. If you're having trouble, that's fine. We'll go through it as soon as I'm back. Okay, so yeah, so let's see. We got f of t is equal to p times e to the rt. P is going to be 100, like we were saying. The rate is oh, that's my bad. I made you guys mess up there. I was being sloppy. We notice it's going to decay, right? There's not going to be more of it over time. It's going to decay, and so the r is going to be negative, right? And so we're going to plug in 3 for, so sorry about that, but we're going to plug in 3 for the x, so we get to the negative 0.519 power, and then if we calculate that out, we get 100 times 0.59512, which is going to be equal to 59.512. All right. Now, that was it in terms of exponentials. That was the entire lesson, and that was a lot. That was my longest video by 3 times as much as the last longest. We're at 31 minutes. So if you need to go back, that's perfectly fine. If I didn't explain something well, that's also perfectly fine. I'm not very good at this. This is the beginning of me doing this. So I think I'm going to put some links in the description about other possible like articles or videos that go into this better or the same way or different ways than I do, just so you can get a solid grasp on this, because the rest of the unit depends on this, and you guys can do it. It's just I'm not the best teacher. So, but anyways, thank you for watching this. Bye.